If a PMOS FET with W over L is equal to 77.8 has a VGS of some value and VDS of some value, we're asked what is the magnitude of the drain current in microamps. So let's solve for this. We're going to use these notes that are linked below the like button, and a super obvious way to know that you're going to use this is if it has a lambda. Now if it doesn't have a lambda, we are going to use the previous notes, or the same notes but the previous part, where that looks something like this right here, where NMOS in triode, NMOS in saturation, or since we have a PMOS here, it's more like a PMOS in triode and PMOS in saturation. You'll find that if we use this equation, we can always use it. If our lambda is 0, we're just going to get to this equation. But again, if we have some lambda value, we're going to use this. Since we don't, just going to make it a little bit easier on ourselves, and we're going to use this. Now, is it in triode or is it in saturation? We can look at this. So let's look at our VGS and our VTP. We're going to combine them and compare it to our VDS. So our VDS is 1.8. We'll do a 1.8 here. We need to see the sign. Then we're going to have our VGS, which is 0.82, minus our VTP, which is a negative 0.5. So we'll have this be a positive to combine them together. And we see that this is going to be approximately 1.32. Now, this is less than our 1.8, so 1.8 is greater, meaning our VDS is greater, meaning that we are in saturation. So we're going to use the equation where we're in saturation. So that means we're going to use this one right here. And if we plug in our values, which I have done right here, we are going to get our answer to be, and the 10 to the 6 is because we need this in microamps, 159.334. And so that is the answer to this problem. If you have different numbers, you would just use this equation, and I've explained why. Because if we have a lambda, we would need to use this. Otherwise, we can simplify it a little bit more and just go with something like this. The important part is to check whether we're in triode or in saturation though.